Thank you to the organizers for inviting us for showcasing this structure. I think the entire day, since morning, we've been talking about a lot of technologies and a lot of techniques and a lot of engineering. I'm here to talk about a slightly different part of steel, which is where we feel that steel is more fluid than we actually think it is. This was a competition which was launched by Tata Steel, I think, 2.5 years back. And it was an idea to do a sculpture using Tata structura. We were one of the finalists, and only in last November, we were called to actually do this sculpture at the site. This is now standing at Jamshedpur. The sculpture actually embodies the energy of billion Indians and epitomizes the quest for a glorious future. We have been using parametric in our architectural works for a while, but never had the opportunity to create such a distinct structure. Now, the issue is that, again, if I look at parametrics being used by Zaha Hadid and the way we use it, it's two different worlds. Her works are more sculptural, ours become very sort of rigid. So, quick short thing about us. We are a practicing architectural company in New Delhi. We have a history of about 25 years. Some quick things about this structure. This is an 11-meter tall structure. It is 9 tons in weight. It uses Tata structura all the way from 300 millimeters diameter to 40 millimeters at the top. These are 3 cantilevered Archimedean spirals. So when we started the project, obviously, like most of the architects do, we dreamt. And then the big problem was how do we build it, because we do not have a helical bending system in the country. We are able to bend helix as parts when we are doing staircases with smaller sections. But when the helix becomes reducing, it becomes a problem. So the entire project was actually handcrafted. It was manually bent. And it was actually a beautiful scene looking at how they were bending the 300 diameter pipes manually, heating sections and bending it to different elevations and different curves. Of course, there's a lot of symbolic ideologies to this sculpture. It is basically, the form is basically Agni, and it's a revered form in the country, whether we are, we come from various communities, but for all communities, I think the fire means a lot. So we worked on this, and we also talked about, the fire had a different layer, and where we're talking about, we brought in the ego and the alter ego, and there were 3 spirals that were born out of it. The form is achieved through 3 Archimedean spirals that form the 3 corners of triangle with different numbers of revolutions and pitches, finally meeting at the top. These are actually not connected at the top. These are 3 independent spirals. That is what makes the structure beautiful, because it sways. There's a standard deflection of about 7 centimeters at the top when there's a good wind of gust. But still they don't touch each other, so there is no clanging. That's how the entire process happened. The first sketch that you see on the left was basically a flame sketch. And then we talked about how it would rise as a spiral. And then we had laid. And if you look at the bottom, it shows how the entire spiral actually culminates as a bindu, which is the center, the epicenter of the space. Finally, we were very glad that Tata Steel gave us a very, very prominent site to put up the structure. It is now at Jubilee Park at Jamshedpur, bank opposite the Tata statue. And it has a very beautiful 360-degree view. So now you can actually move around the entire sculpture, because the sculpture is not static. It is very dynamic even when it is not lit. So we've already talked about the 11 meters. It uses, this is all hollow steel, so we had to close all the end pipes so that the longevity is improved. Of course, when we were ideating, we were talking about how the three different spirals will work at different levels. And that is when parametric was really used. Because when you're talking about three reducing spirals having lot of spikes at every level, there's bound to be hitting each other. So at various levels, the pitch of the spiral was reduced or increased so that they did not hit each other. We actually were thinking of using very small webbings, as my friend just talked about stiffeners. So we were talking about using stiffeners initially for putting the spikes onto the spine. I'm calling the things that coming out of the main spine as spikes. Of course, the choice of tube was very simple. We went for the circular tube because in all axes, the strength is the same, the flexure is the same. And at the base, what we did was that the cantilevered spiral was trying to fall in. So very low at the base, we've actually connected the three spirals. So you do not see it because the entire sculpture is actually sitting in a bowl. So the bowl is what actually holds the key to how the spiral stands. That's how the thing is connected. The drawings for this were very difficult because we are a very simple architecture company and we've always done linear works. Suddenly you are doing something which is changing position in all the three axes. And I was sent back to my drawing board when I was a student, and there we used to do orthographic projections. So literally we sat down and we did orthographic projections for each of these. And what was interesting is that every tube, so these are reducing tubes, so it's going from 300 to 40, but every tube is 300 or 250 or 200. So the tube is not actually tapering. It's like an antenna. It's telescopic. So every tube was taken, and every tube's elevation and every tube's radius was defined. And as I said, it was manually done. Very simple connecting details for the tubes. And what you see on the left of your screen is the most interesting thing, because this whole sculpture was done in a month's time and built in Kharagpur and shifted to Jubilee Park. So if you see the last middle photograph, that is the picture of the entire sculpture being carried on the trawler from Kharagpur to Jubilee Park. And this is the picture. I mean, this is my favorite picture when it was being installed at Jubilee Park. The entire sculpture was just kept in position. And when we saw it finally, it was a delight. Of course, these are some of the shots. So, yeah, so I'm just closing in. So the entire idea of presenting this was to actually take you out of this rigidity of the material and talk about the fluidity of the tubes. We work with tubes, so yeah, that's all. And probably one quick thing I need to talk to everybody is, probably we need to take the education of steel to all architecture colleges, because I'm an educator myself, and the biggest problem I see is students of architecture are taught a lot of concrete and brick, but steel is not there, probably also because the teachers who are teaching them do not know about steel. Thank you.